thought I would talk you through a problem very similar to the first one in lesson 20, and here it is. The question is, will a kilogram of air, which is 20% oxygen gas by weight, and oxygen gas, remember, is formula O2, will that much air, a kilogram of air, be enough to burn 100 milliliters of alcohol? Burn, of course, means combustion with oxygen. So the reaction that we're talking about is down here, and I've balanced it. Here's the formula for alcohol, normal ethyl alcohol, or ethanol. Takes 3 O2s to make 2 CO2s and 3 water molecules. So the question is to see if there's enough air to burn 100 milliliters of alcohol. We're told in the problem that the density of alcohol is 0.79 grams per milliliter. So that's going to let us change the volume of alcohol into grams of alcohol. There's another question too. If this is enough air, how many grams of carbon dioxide will be made when you do this burning, combustion? I figured out the molecular weights of all of the chemicals involved in this balanced reaction. I don't think I'll need the molecular weight of water, but I did it anyway. So here's the first question. How many grams of air will burn 100 milliliters of alcohol? I know I want kilograms, but I'm going to change the grams to kilograms in a second step right here. That's because I'm going to run out of room over here on the paper. Alright, so I change first the milliliters of alcohol into grams of alcohol using the density, and then I remember what these molecular weights always let me do. They always allow the moles of a substance to be changed into grams of that substance, or the other way around. So in this case, I need to cancel the units of grams of alcohol and convert it into moles. So I'm using the molecular weight of alcohol. The key to all these problems is getting to moles, because the balanced reaction tells you what the relationships are between these chemicals in terms of moles. 1 mole of alcohol needs 3 moles of oxygen to burn it up. 1 mole of alcohol produces 2 moles of CO2. So this mole-mole conversion factor comes from the balanced reaction. I convert the moles of alcohol into moles of O2, from moles of O2 into grams of O2 using the molecular weight of oxygen gas this time, and then finally use the information in the problem about the composition of air and convert the grams of oxygen into grams of air. So I do the computation and I get 820 grams of air. Converting that to kilograms, remembering that there's 1,000 grams in a kilogram, I get 0.82 kilograms of air. So the answer to the first question is yes, a kilogram of air is enough. Calculating the amount in grams of CO2 made is fairly easy. It's just the same as the first calculation. I run through this very quickly because I'm going to run out of time here in my little 5-minute movie. Milliliters to grams of alcohol, grams of alcohol again to moles. It's just the same as up here. 2-to-1 ratio in moles in the reaction. Convert to grams, 160 grams of CO2.